Most MCP frameworks handle tool registration changes automatically. But what happens when you need to manually trigger updates to tool, resource, or prompt lists? You'll see how FastMCP's context object gives you direct control over change notifications, whether you're dynamically modifying components at runtime or need to force sync client-side lists. The pattern uses 3 simple async methods to broadcast updates, ensuring clients always see the latest state of your server.
At MCP, Tool. Async Def Custom Tool Management CTX, Context, SDR. Example of manual notification after custom tool changes. Hash after making custom changes to tools. Await CTX, send tool list changed. Await CTX, send resource list changed. Await CTX, send prompt list changed. Return notification sent.
This demonstrates the change notification pattern in distributed systems, where components must signal state changes to maintain consistency across clients. The concept revolves around explicit event propagation. When backend resources like tools, prompts, or data templates are modified, the system broadcasts updates to all connected clients. What makes this distinctive is its push-based model, where the server proactively notifies clients rather than requiring them to poll for changes. The pattern operates through a centralized context object that acts as both a capability provider and an event dispatcher. Instead of embedding notification logic within each resource handler, you delegate change signaling to the framework via dedicated methods like send tool list changed. This separation of concerns keeps your business logic clean while ensuring clients receive timely updates, whether they're AI agents, front-end UIs, or other services. This matters because it solves the stale data problem in dynamic systems without coupling your tools to transport mechanics. Clients always work with the latest state, reducing race conditions and manual refresh logic. The trade-off is slight overhead from notifications, but the benefit, real-time consistency across distributed components, far outweighs it for interactive applications like AI workflows or collaborative editing tools. Let's break it down line by line.
At MCP, Tool. Async Def Custom Tool Management CTX, Context, SDR. Example of manual notification after custom tool changes.
This defines an AI callable tool using FastMCP's decorator pattern. The @MCP tool decorator exposes this function to AI models, while the context parameter handles logging and progress reporting. The docstring becomes part of the tool's schema, defining its purpose for AI systems.
Hash after making custom changes to tools. Await CTX, send tool list changed.
This triggers a client-side update notification after modifying the tool registry. Required when making programmatic changes to tools, it ensures the AI model's tool list stays synchronized with the server's current state. Part of FastMCP's reactive architecture for dynamic tool management.
Await CTX, send resource list changed.
This notifies the MCP server about changes to available resources, required after manual tool modifications to keep the AI's resource list in sync, preventing stale references during execution. Part of the 3 notification pattern for complete tool state updates.
Await CTX, send prompt list changed.
This notifies the FastMCP runtime that prompt templates have changed, forcing AI tools to reload their latest versions. Critical for development workflows where prompt iterations happen frequently, it prevents stale templates from being used. Part of the bulk notification pattern shown here for tool, resource, and prompt updates.
Return notification sent.
This return statement provides explicit feedback that the notification process completed successfully. In FastMCP tools, Returning a string creates a user-visible response, while omitting it would make the tool appear silent to callers. The message confirms the 3 notification events fired as expected. Notification pattern. The context object's notification methods enable explicit state synchronization between server and clients, ensuring all connected systems maintain consistent views of available tools, resources, and prompts. Manual notification calls are only necessary when making changes outside FastMCP's automatic notification triggers during request processing. This pattern eliminates polling while maintaining real-time consistency across distributed components.
The notification that announces everything must itself remain silent.